Okay, welcome to Cloud Security Office Hours. It is August 1st. This is, believe it or not, our 129th session on Cloud Security Office Hours. That's completely insane. Thank you, everybody, for being here. We're going to have a presentation from Patrick Burke. And with that, I will hand it over to Patrick.
Awesome. Thanks, Sean. Yeah, longtime lurker, first time presenter. Been a solutions engineer for about 3 years now, maybe 6 weeks at ChainGuard specifically, who offers minimal containers, and that's what we'll be talking about today. Container images that, from a security and compliance perspective, have really been minimized in the number of packages that they actually have in them. So we'll kind of be reviewing the problem statement around what are the trends we're seeing with vulnerabilities in the wild, what we're seeing with container usage and adoption, and what we're seeing with open source consumption. We'll talk through a couple reasons of why you might want to investigate, evaluate, potentially acquire a solution around minimal containers, really around compliance as well as reducing the manual effort that developers have to spend patching vulnerabilities. And then we'll also be speaking to some of the non-paid, the build it yourself versions, as well as some of those offerings that you might find on the market. Like Sean already said, if you have a question, drop it in the Zoom chat, raise your hand, come off mute, just make it known and we'll try to get to it as soon as we can. So some of this is going to be review for many on the call, but I still think it's important, especially for some of the newer folks here. But what exactly is a vulnerability? It's really just a flaw or a weakness in a piece of software or a piece of hardware. And normally it's somewhat specific. It's going to be tied to a specific open source project, maybe a couple open source projects, or maybe a vendor offered piece of software or hardware. And it's normally prepended by the letters CVE. For anybody who's been in security for at least 3 or 4 years, you probably have this CVE identifier burned into your brain, 2021 44228. It was one of the vulnerabilities related to Log4Shell. So the vulnerability that affected the Java logging library. That's just one example of a critical vulnerability. Here's another here, 2014-0160, related to Heartbleed. And here's just another third example of a SharePoint CVE that was discovered in the last month or two. And essentially, these have traditionally been fixed or patched by upgrading to a safe version. So at least for Log4j, I believe it was initially fixed in version 2.15.0 release candidate 1, and then it was fixed in all of the versions of 2.16, the 2.16 family. Some of those affected versions included, though, versions within the 2.12 family as well as the 2.13 family. And we'll be talking about this in a little bit, but that was the traditional way to patch these vulnerabilities. I would still say it is the way to patch these vulnerabilities, but the way that minimal container image solutions is going about this is working to remove as many packages as possible that are irrelevant for the app's functionality to maybe avoid some of these vulnerabilities. Like Kyle, I see you have a hand up.
Basically, what you're saying is that you're trying to reduce attack surface, but in the traditional way of upgrading, that also potentially produces another vulnerability, which is that that an attacker might be able to downgrade the from the safe version to the flawed version. So, would you like to add anything?
Yeah, so I'm not sure if that's exactly an attack vector, and if anybody else has some thoughts on that, they can weigh in. Really, just trying to say here that the way to remediate these vulnerabilities is by bumping up those versions. Good question, Kyle. Some of the trends that we're seeing with vulnerabilities, I'll pause there. Striker, question.
Just to just for my own information, the reason you're not sure it's an attack vector per se is because it would already need internal access and accelerated access and internal access in order to be able to downgrade to said version to exploit it, because at that point you're kind of in and can do it anyway. So why would you downgrade it to then exploit that, is what is that the logic, a logic path anyway?
Yeah. I just
Okay,
wouldn't
just wanted to make
understand
sure.
why that would need to, why an attacker would care about downgrading a library, right? If they're already on the system and can do something like that, they probably already have enough privileges.
Okay, that was what I thought the logic was, but wanted to make sure. I wonder what, that's a sidebar. I'll save that.
All good. Let's I'll note that down for the sidebar if we have some time at the end. Cool. Some of the trends that we're seeing around vulnerability specifically, surprise, surprise, if we're on LinkedIn vulnerability forums, is that year over year vulnerabilities are going up. So really the trend is for 2023, there are more vulnerabilities discovered and detected than 2022, than 2021, at least for the past 8 years. I believe the CVE identification program has been around roughly 30 years. So that trend probably more or less stays true. Not necessarily for every year, but when we look at this second graph here, um, we see a concerning uptick or acceleration year over year of vulnerabilities that are discovered that makes us kind of think, hey, maybe we cannot throw full-time software engineers and developers at this problem to patch these vulnerabilities or throw more security engineers at this problem to help burn these down. Um, so that's the trend around vulnerabilities. Let's talk through what is a container. So essentially, containers are a way to solve the problem of, hey, it works on my machine. If I'm a software developer at a company, works on my machine. I'm not sure why it doesn't work on my colleague's machine or why it doesn't work on prod. But essentially, this could be a plethora of reasons. I could be running Python 3.12 and somebody else could be running Python 3.9. There might be different environment variables on my computer as compared to theirs. There's just no way to guarantee that consistency traditionally of the app running. Containers work to solve that problem. It's really just a standardized unit of software that's going to be able to package up an application source code, its dependencies, so its libraries and configuration files into one unit that can then be run essentially on many different environments. If my container runs on an EKS cluster or within AWS, it should be able to run the same on Microsoft Azure as GCP as on-prem. And just, in case we want a diagram here, really when we're talking about containers, there is going to be a physical server that on top of that, there is an operating system. And on top of that, there is a container runtime such as Docker. And those containers or containerized apps run on the container runtime. So essentially, all of those apps are sharing the same underlying operating system and underlying kernel. Whereas traditionally, what you had is that there was a physical server with a hypervisor on top of it. And on top of that hypervisor or that virtualization layer, there were multiple guest operating systems. So this kind of goes to show how containers are also more efficient in that they can share that operating system. All right, in terms of other terms that I think are essential before we get into the rest of the conversation, container images are just the way that you distribute containers. It's the actual artifact that you pull down to your machine that a Kubernetes cluster pulls down to itself to run those images. So it's how you distribute them. And normally those are going to be stored in container registries. You're not emailing container images around. There's going to be a centralized repository such as Docker Hub or AWS ECR. And I do like to make this distinction is that if we're going to generalize it, there are almost two types of container images. There are application container images. So Nginx is already a built web server. It might require a couple configuration files or a couple HTML pages. Same thing with Redis as a database or cache or MySQL as a database. These are all built applications, but for developers that are building a Golang application or a Python application, they would actually base it on a base image, a base Golang image, Python image, maybe Ubuntu image if they're unfamiliar with how they should be writing those apps. The second term that I want to make sure we cover here is Kubernetes. When I was thinking about this past week, I think the best analogy for Kubernetes, and there are probably 1,000 analogies on it, but if I know a lot about building a shed, I could just go into my backyard and build it, lay the concrete foundation, build up the walls, wire it up if I need lighting, and that's perfect. I don't need a project manager if it's just a one-man show. But if I want to contract this work out to a team of individuals, maybe one that knows concrete, another that knows carpentry, and a third that knows electricity, just to make sure they're all working together in tandem and following the blueprint, I probably want a project manager. Essentially, those individuals that I've hired, those are the containers, and Kubernetes is the project manager there, making sure that all of those containers are orchestrated. And Kubernetes essentially helps with resilience. If one of those workers calls out sick, the project manager should be able to call in another worker. If a container goes down, Kubernetes should be able to bring another new one up. And Kubernetes also helps out with networking, so communication between those containers as well as storage of any of those containers. And some of the more common implementations that you'll probably see in maybe a couple screenshots are AWS Elastic Kubernetes Service and Azure Kubernetes Service as well. And these just help out with the management of the control plane of those Kubernetes clusters. And maybe what we're seeing from the trends in containerization, and I do see a fair amount of messages in the Zoom chat. If there's any burning questions, let's cover those and somebody come off mute, but if not, no worries.
It's the notes for side later, but I'm paying attention and everyone else is paying attention as well. So you're good.
Cool. Thanks, Striker. All right, trends around containerization. I think everybody broadly agrees or maybe even assumes containerization adoption is increasing year over year. I kind of wanted to challenge this assumption and like just verify it. But what we can see is that Red Hat back in 2022 said that 70% of IT leaders we surveyed work for organizations that use Kubernetes. Gartner predicted just a few years back that 70% of organizations will run more than 2 containerized apps. So there's some legit form of adoption, is what they predicted. And Docker back last year said 80% of developers use containers, at least in development, while only 17% do not. And here's an interesting stat from Wiz's Kubernetes report is that there was a slight uptick between 2023 and 2024, about 8% in the number of Kubernetes clusters that were self-managed, that weren't using AWS EKS. They actually rolled their own control plane on virtual machines within AWS, which indicates a very high level of competence in Kubernetes and probably a high level of competence in containers. So I found that stat rather interesting. These are all solid stats here, but I thought it would be really helpful if we could see what AWS, Azure, and GCP have to say on the matter, because they run dozens or hundreds of data centers across, across the whole globe, right? So if we're looking at some of the numbers from them, AWS across its EKS as well as ECS projects, and this graph goes back to 2018 up until last week. We see a constant level of interest from their customers in opening pull requests. That's what we see with the green here for the past 7+ years. And then we see at least a burn down of some of those feature requests and pull requests over the last 2 years. I imagine AWS didn't just start, innovating with these container products that they offer over the last 2 years. So I'm not sure why it's this brief. Maybe they were working off of private GitHub repos, but essentially this is just showing that AWS is committed to innovating on those platforms. Azure releases new versions of AKS at least every month, or at least at least every 2 to 3 weeks. And GKE has a pretty well documented, or GCP rather, has a pretty well documented list of features that they are rolling out for GKE. I'll pause there. Kyle, I think I see your hand up.
So about that earlier stat you were talking about, the one about them rolling their own solutions, is that it could be a sign that the control plane, the native control plane that the cloud offers, might be costing them too much, or they might be looking at a multi-cloud solution. It could be a sign of their incompetence rather than competence, because rolling your own control plane is pretty complicated. And like with rolling your own crypto, if that's any analogous at all, what I'm trying to say is it might be a good idea to use the standard cloud control plane unless you're playing on multi-cloud, because that has a lot more support.
Yeah, potentially. I did make an assumption there, right? So like when we look at that whiz graph, and this is what Kyle's referring to, this could be indicative of a couple things. I made the assumption that, hey, this indicates a high level of Kubernetes competence. It could potentially mean that some organizations are thinking incorrectly that they know enough about Kubernetes. Maybe it's a cost consideration, maybe it's multi-cloud, but good call out, Kyle.
The one thing I'll
Sorry,
say,
just go ahead.
now I was saying back when I was at GCP, I was working with some of Google's biggest customers, and a lot of them were kind of on the cutting edge of using Kubernetes for things. And what they ran into a lot is the cloud providers have to put certain controls around making sure their versions of Kubernetes work for all their customers, and that sometimes comes with limitations. And so a lot of the folks that are at these companies that are rolling out their own clusters and control planes and managing that themselves, they have the skill set to do so, but they also like, in my opinion, most of the time have a valid reason to do so, because they're at some limitation for what the cloud provider flavor of like Kubernetes provides.
And I also suspect self-managed here may be a bit of a misnomer. These are not cloud managed. They're not EKS in AWS or AKS in Azure, et cetera. But they might be OpenShift, they might be Rancher, they might be something else that is not just vanilla Kubernetes. And even running vanilla Kubernetes, there are good established patterns there today that mean you're not, to borrow Kyle's words, you're not rolling your own control plane. You're configuring Kubernetes yourself instead of using EKS as defaults for it. So I wouldn't read too much into that number.
I would argue definitely multi-cloud is one aspect of it. Certainly goes for us. So SAP has its own Gartner Kubernetes distribution, which allows us to run it on both bare metal as well on any of the cloud providers, so that to the development and solution teams, it's the same wherever, right? So that may be a good reason why you do it. There may be on-premise workloads and as well, and then everybody uses the same platform. So that's a good one. Another is versioning. Some of the cloud providers can be very aggressive with how quickly they follow the versioning, and that may not match your enterprise pace. And then you don't just want the landscape underneath you to change if you're not ready for it.
Yeah, great insights. I appreciate the detail on versioning and multi-cloud. All right. The other term I think we need to define here, that again, this might be some review, is what exactly is open source? So open source software, sometimes called free and open source software, so OSS, refers to software where you can, if you're a internet user, you can get it off of GitHub, an FTP server. You're just able to access it, run it potentially in your apps, modify it. It's just freely available. I kind of broadly categorize this into three main flavors of open source, but this could be an overgeneralization here, is that you have open source operating systems, such as Linux and many dozens, probably hundreds of distributions of Linux that anybody can pull down and run. There are open source languages or language runtimes, such as Python, Golang, and the JavaScript ecosystem. And then you'll also have libraries or dependencies. So things like curl or OS level packages, things like Python libraries. And why would maintainers spend hours, days, or weeks maintaining something if they're just going to give it away for free? Well, I think there are a couple reasons here. They might be, maybe fractionally financially incentivized. Maybe they get some small donations from their user base or from their fan base, or more often than not, it's a passion project. They've been working on this for a long time. They view this project, as one of their own. They want to keep developing on it. And why would a consumer like to consume open source? Really, it's because they want to spend as little time and effort as possible on building whatever that open source project actually achieves. Really, open source is kind of just a fact of life at this point. Nobody is trying to build all of the code they need in-house. They're gonna have to leverage open source. So I think this picture kind of demonstrates that. Um, Kyle, I see a question from you.
Yeah, I just wanted to add a lot of tech companies hire people specifically just to work on open source because they rely on the open source code for their proprietary code. So, like things like Steam putting a lot of money into Proton and Wine, and Microsoft maintaining Visual Studio Code, and GitHub GitHub hosts all the all the open source software. So yeah.
Potentially the larger companies, yeah, would hire engineers who spend some of their hours during the day maintaining those open source projects just because they're heavy users of it. Yep, Kyle. Dave, question?
Yeah, it's really off the back of Kyle's point as well. I mean, making it open source makes it available, right? Makes it available to everybody, and encouraging folks onto the platform can sometimes be exactly what you want. Like what you'd said as for one of your points there was, yeah, making it available because you're maybe incentivized by how the amount of users on the platform, but having it openly available means that you've got a lot of the gaming platforms at the moment that are openly encouraging. I think Roblox would be a prime example of it, where the platform itself is open, but then you've got your microtransactions and everything else within it that you're going to get sucked into. So I was just trying to fortify both Kyle's point on it, because I think I got it with Steam and one of the points that you'd made already.
Yeah, I
There was
appreciate
a
you putting it in.
there was a very cool keynote actually at Sector last year, where they talk about vulnerabilities in the open source. And one of the big questions was, well, why do we use it at all? And they're like, well, it's so integrated into everything that we do these days, from NASA and super secret projects all the way through to, Microsoft and basic things. So OSS is absolutely needed. And it's like, to your point, Patrick, it's not going anywhere.
Totally. And that's what the big players back up. So even Google has measured that open source software components now account for 77% of modern applications. Granted, I have not looked at how they empirically measured these numbers, but I do have a colleague that worked on a project where they measured the open source contents of 5 commercial Java applications, and they actually found that open source consisted of anywhere from 76.2% to 99.9%. So if there were 2,000 lines of code, only 2 of those would have actually been written by those vendors when they dole out those products. I think I have my numbers right there. So those are the trends that we're seeing around open source. The big why around it is that it provides a lot of value for the consumers, and essentially it's not going anywhere. And then also Kubernetes has another play here in that when you're trying to break your application up into microservices or containers, things can get complicated quickly. You might need to manage certificates. You might need to worry about how do we do CI, continuous integration, continuous deployment. And you might also need to worry about how are we going to do things like DNS. Those examples will be apparent here in just a couple minutes, but so when you're running Kubernetes with AWS, Azure, GCP, especially the managed versions, so EKS, AKS, AWS is automatically going to deploy a container or multiple containers on your nodes for observability's sake, maybe management's sake. So they are also going to be deploying their own software, potentially it's open source software, onto your workloads, onto your Kubernetes nodes. And when we were talking about, DNS, cert management, maybe observability with Prometheus, these are very popular open source options that will either be deployed by default in the terms of in the case of the DNS plugin, but also if you want to do anything semi-advanced with Kubernetes, you're probably going to want to look at some of these open source solutions. And if you want to look more into them, the Cloud Native Computing Foundation has a pretty solid list of projects around this. All right, so we kind of talked about the trends around vulnerabilities, containers, and open source. Specifically, we'll be walking through a demo of, hey, I've written an application. Now I want to containerize it, and I want to do so in a secure manner. So let's break open the terminal here. And let me run you through what we have. We have a simple Python application. Let's see if we can bump up the zoom. We have a simple Python application using Fast API, just an open source dependency or open source library that's essentially just going to run a web server and returns a very simple message. It's so simple, it's probably not worth running here, but this is our application, and I am going to walk you through how many vulnerabilities we get versus different base images. But first here, I just want to see that there's no vulnerabilities in this specific Python application. So the only thing we're importing is actually Fast API here. So let's go to the relevant directory here. This is all underneath the Python directory. And we will just scan our project with Trivy, an open source vulnerability scanner, I believe first released by Aqua. And we will take a look, and it looks like we are seeing 0 vulnerabilities on this project, on requirements.txt. So let me just mark that down here, because we are going to be walking through and documenting this for these other scenarios that we have here. We are seeing 0 total vulnerabilities, which indicates 0 critical and high vulnerabilities. That's great. Now, if I'm unfamiliar with containerizing my applications, I might look at some Medium blog articles, I might look at YouTube, and they'll tell me, hey, really simply to get started, you'll want to use from Python. Use that as the base image for this container that you're about to build. This is probably not the most secure option. This definitely is not the most secure option. But the tutorial will go on to say, here's how we set up the working directory within the container image. Here's how you copy that requirements file over and make sure all the requirements are actually installed. And here's how you'd actually run your application. So with that, we are going to use Docker build here to build this application on the base Python image. So we are going to run Docker build, and we're going to tell Docker that we're using the Python Docker file, and we're going to tag this with -t fast API app Python. All right, built pretty quickly, probably because I've run this before. And let's see what the vulnerability count is. And we are going to run trivi image fast API app Python. And that's a lot of output here. We'll see that it goes past my terminal. So we're actually going to need to output this to text file. Let's do that here. All right, so vulns app python.txt is what we have. Looks like there's 1,700 vulnerabilities. We've just introduced 1,700 vulnerabilities by using the raw Python image off of Docker Hub. You know, if I were a developer, I would almost think this is a mistake. So let's just grab this number here, just for the sake of the table and documenting our progress. But there are, at least for our app when it's on our Python image, there are 1,699 vulnerabilities. And of those, for critical and high, there were 269 total. So let's just grab that number. All right. Yeah, so I probably want to scan the base image just to make sure that our work was correct here. So let's run trivi image Python. And because there's so much output, let's just pipe this over to python.txt. And we'll check this. And lo and behold, yep, the base image is the culprit here of introducing those vulnerabilities. So we will just say the same thing for the Python image. If I do some more research, or if my organization is any somewhat familiar with containers, we are going to try to use something slimmer, something that has a lot less dependencies, is a lot more secure. So a common option here is on Docker Hub, you can actually find the Python Slim image, is what they call it. So instead of using from Python, we're actually going to use from Python Slim. And we're not going to change anything else about our application. We've only added 5 characters to the Docker file just to indicate that this is tagged Slim. So let's run this here. I am going to run Docker build, feed in the Docker file for Python Slim, and I'm also going to tag this Python Slim. And we'll run that. And we are going to scan this with trivi again. And let's also just pipe this over to a file just in case it's too big. All right, so we have our vulnerability results here in this file. Looks like we have 90 vulnerabilities from the base image, which is absolutely better than what we had before, but there are still 2 critical and 7 high. Why this is important is that even though we've reduced it by so much, those are still vulnerabilities that I'm going to need to worry about as a developer, essentially. Let me make sure that was 9. Yep. That's 2 critical vulnerabilities and 7 high vulnerabilities. I'm still going to have the security team notifying me about these, trying to make sure they're remediated. That's 9 extra things I shouldn't need to worry about. So let's really go for broke here and try to eliminate all of those vulnerabilities, maybe all 90. Python on Docker Hub also offers a Python Alpine version. So instead of using potentially Debian for some of those OS level dependencies, we're going to be able to use Alpine, which is a minimal Linux distribution, probably the best open source alternative here. And so what we're going to do is we are going to build this off of the Alpine Python image, which we've tagged here. And similarly, we are going to set a couple environment variables, maybe add a few OS level dependencies before running that app, similar to the other Docker files and the other container images. So let's run this. We will run docker build dot. We'll feed in the Docker file name, and then we'll tag it fast API app Python Alpine. And then let's scan this as well. We'll scan it again with Trivy. And let's see how many results we're getting. We're getting one result, one vulnerability from Alpine. And it looks like 2 other results here. So 2 other results just from Python specifically. So in total, this is going to be 1 critical vulnerability and 2 high vulnerabilities. So we can mark that down, just continue tracking this. All right. And the final option that we're going to have here is using a minimal container image offered by a vendor such as ChainGuard. So let's do that here, is that we have this Docker file that uses a ChainGuard base image. We're going to pull from ChainGuard's registry, and we'll set the working directory. We'll set a couple environment variables. We'll install those requirements, and essentially then we'll run the application. All right, so let's build this container image here. All right, now that's built, we will scan this with Trivy, and we'll pipe the results over to Vuln's app Python CG. And let's take a look here. It looks like there are 0 vulnerabilities in the OS level dependencies and 2 vulnerabilities elsewhere. So looks like we've remediated or removed all of those critical vulnerabilities. We only have 1 high and 1 medium. So let's just mark that down in the table here. Is that in total we had 2 and there was only 1 high, just so we have this here. Really, we see that it's pretty similar, at least like scanning these images today, between like Alpine and ChainGuard. So let's talk about what some of the benefits are from getting a minimal container solution. Let me know if there's any questions on the demo. I know we were there for probably 10 or 15 minutes.
It was really interesting. There was lots of not questions, but just observations, which TLDR is, boy, AppSec sucks, in order to try and prioritize which things you end up trying to fix. Because at some point, you're going to get to a point of minimum viable fix, like minimum as few vulnerabilities as you can, but you still have to do something about it. And God, I'm so glad I'm not an AppSec.
I was going to add that what ChainGuard seems to be selling to me is is library security as a service, like an MSP, but for containers. Is that true, or am I off base?
So what ChainGuard and other images offer, or excuse me, other vendors offer are, the base offering is container images that you can either drop in for whatever you're using for Nginx or Redis or like one of those apps, or that you can build off of. That's essentially what it is.
Thanks for the clarification,
I
Patrick.
think it's worth mentioning, Patrick, that it's not just the fact that they're images or base images with a lower number of vulnerabilities. It's that there's usually an SLA tied to fixing those images when new vulnerabilities come out, right? So if you build these images into your pipeline, in other words, you tell your developers, these are the approved images, these are the golden images that we use, and here's where you find them. You've improved the quality of your pipeline substantially, right? And it will stay that way. Entropy, starts at the base image.
Totally. Yeah, I was sticking to my script a bit there, but SLAs is definitely something that we're going to talk about here. One of the reasons that you might want, one of these minimal container solutions is for compliance. A very popular compliance framework is FedRAMP. And FedRAMP stands for the Federal Risk and Authorization Management Program. It's not the only compliance framework or standard that might incentivize or mandate specific SLAs around CVE remediation. But if you want to sell to the federal government and the federal government agencies for those big contracts, you're going to want to make sure you're FedRAMP authorized. And getting FedRAMP authorized, especially around making sure you're remediating CVEs on time and consistently, is not easy work. It's either going to require a vendor that provides you these SLAs or very strict internal controls on the software that you're releasing. Specifically, those CVE remediation deadlines are critical vulnerabilities should be remediated within 30 days, high vulnerabilities within 90 days, and medium within 180 days. 30 days is really just 4 weeks. So that's a pretty tough timeline to match, even for critical vulnerabilities. So that's the main call out there. And like Sean was mentioning, one of those key offerings, besides images, but like rather support, is SLAs for CVE remediation. So in terms of critical, you're normally going to get way under that 30-day mark if you're potentially purchasing and using a solution like this. And it's not exactly related to minimal container images, but just because these minimal container vendors want to help out customers with their FedRAMP requirements, they are also going to offer container images that are FIPS certified or FIPS validated, making sure that, and for those who are unfamiliar, that stands for the Federal Information Processing Standards. That's making sure that your cryptography is validated, it's secure, and just to tie the two together, FedRAMP encryption requirements mandate that your crypto on your apps, on your workloads, is at least FIPS 140-2 or higher in terms of security. The second reason that you might potentially want one of these solutions, and I'll try to go through this quick just so there's time for Q&A, but developers, they want to build features, they want to get into deep flow states of work and not be bugged by anybody for a few hours or a whole day, but they keep getting interrupted by the security team that notifies them, hey, we found this vulnerability. Hey, we notified you about this vulnerability a week ago or a month ago. Are we any closer to getting it updated? They need to then actually apply the patch. They might need to make sure that all the dependencies line up. Maybe their app won't compile unless they do this. Maybe it will compile, but some of the tests won't pass. So really, long story short, instead of focusing on building features for the business, maybe it's a new product, an AI chatbot. Not that I love that, but if they're building an AI chatbot, they can't do that if they're remediating vulnerabilities for a significant portion of their week. Solutions. So if an organization decides to solve this problem, there are kind of four main solutions to this. They can patch these vulnerabilities as they're identified by their vulnerability scanner. They can implement a golden image program, which is a little more a lot more strategic, rather, which requires more effort from them. In terms of purchased solutions, minimal container images might be an option. And the fourth category we'll talk about in a second is deep loaded container images, going from vendor offered container images and then maybe stripping out some of those packages. So to speak specifically about that patching process, a scanner finds a vulnerability. Security, again, tells that engineer to fix that vulnerability. They might continue to bug, Slack, message them on Teams about it, and then essentially the vulnerability gets patched, and that's the whole process. The advantages to this from the CISO, CTO, kind of the leadership perspective that doesn't see all this toil is that this could be the easy button. They might just not have the budget or might not have the political juice, if you will, to get a golden image program in place or to purchase a solution. This is just inefficient, and the security engineers and developers would be able to tell you this themselves. It can be ineffective. You might not be hitting any sorts of internal SLAs with this approach, and it's kind of miserable, at least from the individual contributor's point of view. So you kind of have tunnel vision when you're in this patching process. But the second option that we have here is building out a golden image program. So the SRE team, site reliability engineering, or the platform team builds a catalog or a library of different container images upon which you can pull, potentially use as a base image or an application image. And then developers are going to build on top of these images. Pretty straightforward. That's a high-level explanation of it, but this reduces vulnerabilities by a significant amount. Instead of some developers who are unfamiliar using the Python Slim image or maybe just the raw Python image, they can start using a more secure, more trimmed down image when they're developing applications. Some of the drawbacks are that this is more effort, more upfront effort, and maybe ongoing effort required from the SRE team to set up this program. And you might have to convince the development teams to pull from your catalog. Developers definitely have an independent mindset. They like to build things when they can. And if something requires them to build off of something that's not on the catalog, they might say, hey, I'm not going to work with security or platform on this. I'm just going to build this app and not worry about it. All right. So for minimal container images specifically, normally the vendor is going to create or use some sort of trimmed down Linux distribution, a very minimal operating system. They will then be very intentional about which packages they're installing for that specific image. So, this might be for Python, for Node. They're only going to try to push the relevant Python packages into the Python app, the Node packages into the Node app. And customers will then pull from the vendor provided registry. And then they'll probably pull that through to ECR, ACR, whatever else they use as like an internal container registry. Again, the pros to this are you get those SLAs from the vendor. They're going to guarantee, hey, we remediate the vulnerabilities in this amount of time. And also they will be providing FIPS validated cryptography as well. The cons are that some testing is still required. If you're using the very, very minimized offering from these vendors, you won't have access to a package manager, which is traditionally there. You won't have access to a web client like curl or wget. So There is also some testing that needs to be done from a technical point of view. And obviously, this is a paid solution, so cons is money here. Debloated container images. This is the last type of solution that we're going to talk about here, is that a vendor offers an image. This could be Python, Node. The customer, and maybe with the vendor, they actually write this app coverage test. They say, hey, in the life cycle of this app, the app should do these 5 things or these 20 things. Whatever it is, they write some sort of config file that will then be run when the container is run. And then there is some instrumentation on that container that actually looks at which libraries and dependencies and packages aren't actually run in the normal life cycle of this app, of this container. And then we're going to strip out those packages. And then the customer uses this new debloated image. I would say the pros are that compared to open source alternatives, this could have fewer vulnerabilities. And normally you're going to have some level of FIPS certification or validation. So this can be used for customers that are looking to sell to the federal government. However, I'm not sure there's a guarantee of an SLA from these types of vendors. And again, it's a paid solution. So it's just going to be an upfront cost as compared to the long-term effort cost of building something yourself. So that wraps up the presentation here. I see, and I kid you not, 98 messages in the chat. So hopefully not all of those are questions. But if anybody wants to voice up, I'm going to read through the chat here.
Oh, you triggered a whole bunch of discussion, so that's always a good sign.
Yeah, definitely,
Awesome
Patrick.
session,
Thanks.
Patrick.
That was great. I'm gonna stop the recording.
Real quick for the recording.
Yep.
One more thing. Let's see here. Neil is a beast, as we all know. Definitely bounced some ideas off him and prepped with him. So thank you, Neil. My other colleague, John Speed Myers, actually put together some tooling for measuring the open source contents of Java apps. He provides some of that empirical evidence. And thank you to all of you for all of the engagement. We could see that in the chat and the questions. So that's it for the recording.
All right, Patrick. Thanks a lot.